morning, students. In our last session, we had discussed subsets and power sets and some exercise problems related to that concept. In this session, we'll see operations on sets. Before that, we need to study one concept, that is universal set. Okay, meaning of universal set is the set which contains all the set in the given context. Is called the universal set. Here see, one set is there which contains all the sets. That means all the sets are subset of the given set. Okay, given context means in the given situation. For example, see, set A is equal to, I am taking 1 comma 2, and set B is equal to 4 comma 5. These are two sets. Okay, universal set, that means one set is there that contains all the sets. Here two sets are given, right? You need to write one set U such that all the sets are subset of U. That means you can take 1, 2, 3, 4 and 5. Okay, in this case, see, A is a subset of U as well as B also subset of U. In this case, you can say that U is the universal set, or you can take universal set U is equal to, see, 1, 2, 4, 5 also. Why? Because see, A is a subset of U as well as B also the subset of U. Okay, two sets are given, that is our situation. In this situation, you can take universal set as 1 2 3 4 5, or you can take universal set as 1 2 4 5, or you can take, see, universal set U is equal to 1 2 3 4 5 6 7 8 9 and 10. Why? Because see, A is a subset of U, B also the subset of U. Okay, clear? Universal set means the set that contains all the sets in the given context. For example, see, I'm taking natural numbers. Okay, natural numbers. What's a universal set for natural numbers? We know, see, natural numbers means it starts from 1 2 3 dash 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 dash. Okay, then take the whole number 0 1 2 3 dash dash dash. Okay, so you can say that for the natural number, one universal set is the whole number, because all the natural numbers are in whole number. Okay, so universal set means the all the given sets are the subset of the one set. That set is called universal set. Okay, okay, and universal set is denoted by, it is denoted by, okay, caps letter U. Okay, here caps letter U represents the universal set. Okay. Next is operation on sets. Basic algebraic operation plus minus multiplication divisions are there, right? Similarly in sets also some basic operations are there. First operation is union of sets. Okay, I'll take, let A and B be two sets. Okay, then A union B is equal to set of all x such that all elements such that x belongs to A or x belongs to B. It's a meaning of union. A union B means you need to write all the elements of A and all the elements of B. If any element repeats, write that element only one time. That's the meaning of A union B. All the elements such that elements may be in A or that elements may be in B. But remember, while writing union, if any element repeats, that means if any element common to both A and B, that time you need to write that element only one time. Okay, for example, see, A is equal to 1 2 3 and set B is equal to 7, 6, 7, 8. Okay, what is A union B? A union B is equal to all the elements of A, that is 1 comma 2 comma 3, all the elements of B 6 comma 7 comma 8. This is A union B. You need to combine both the elements of A and elements of B. Here or is there, or means option. You need to write elements of A as well as elements of B. Then see, A is equal to ABCD, B is equal to CDEF. Okay, find A union B. A union B is equal to, first all the elements of A, B, C, D, and all the elements of B. C and D already you wrote, right? So write the remaining elements E and F. This is nothing but A union B. Okay, take the third example. A is equal to 1, 2, 3, and B is equal to A, B, C. Okay, what is A union B? A union B is equal to, see, elements of A is 1, 2, 3, and elements of B is equal to A, B, and C. Okay, this is how to write the union. Suppose A is equal to empty set and B is equal to 1, 2. Okay, what is A union B? A union B is equal to, see, you need to write elements of A. There is no elements of B. And you need to write elements of B. Elements of B is equal to 1, 2 only. So A union B is equal to 1, 2. Okay. Take one universal set U is equal to 1, 2, 3, 4 is equal to, take 2, 4, 6, 8. Okay. In this case, see, find U union A, means you to combine universal set with the subset. That time what you will get, all the elements of U. What are the elements of U? 1, 2, 3, 4, 5, 6, 7, and 8. Next, all the elements of A. But you already wrote elements of A, right? So if you combine universal set with its subset, then what you will get? You will get a universal set only. Next, take A is equal to 1, 2, 3. Okay, 1, 2, 3, it's a set. Find A union A. Okay, you need to find A union A value. What is A union A? That means set 1, 2, 3. Okay, union again set 1, 2, 3. It's equal to, what you'll get, 1, 2, 3 only, right? See, A union A, what you are getting, it's equal to A only. Okay, observe this. First one, A union B. Here A is the empty set. Empty set union any set, what you'll get, you'll get the same set, right? It's equal to B. Okay, then see, universal set with the any set, what you will get, you will get universal set only. And see, A union A, if you combine A with the same A, what you will get, that is equal to A only. Okay, by this observation, important three notes are there. First one is A union A, it's equal to A only. Okay, and the second note, that is A union empty set. Union of one set with the empty set, that time also you will get A only. Okay, and the third note is A union universal set. A union universal set, then what you will get, you will get universal set only. Okay, these are very important note. First one is, see, A union A is equal to A itself. A union empty set is equal to A, and A union universal set, that's equal to universal set. Next, intersection of sets. Let A and B be two sets. Okay, then A intersection B is equal to set of all x such that means and x belongs to B. Okay, intersection of two sets is nothing but you need to write common elements in A and B. Okay, x belongs to A, that element belongs to A, and that element belongs to B. You need to write the element which belongs to both A and B. Okay, that is called intersection of two sets. Clear? A intersection B is equal to all x such that x belongs to A as well as x belongs to B. For example, see, A is equal to take 1 2 3 and set B is equal to 3 4 5. Okay, in this case what is A intersection B? A intersection B is a common element in A and B. Here you can see 3, here you can see 3, therefore A intersection B is equal to 3. Take the second example. A is equal to ABC and B is equal to CEIO. Okay. What is A intersection B? A intersection B is equal to find the common elements. A is not in B, B also not in B, but C is there, right? One element C, right? That belongs to both A and B. Therefore, A intersection B is equal to set C. Clear how to write the intersection? Writing intersection means you are writing common elements in both set A and B. Okay. Now take the third example. A is equal to 1 2 and B is equal to empty set. Find A intersection B. A intersection B is equal to A intersection empty set. That is equal to 1 2 set 1 2 intersection with the empty set. What's the intersection? Intersections, you are not finding any common elements, right? A intersection B. Okay, that means A with the no elements, you are not finding any elements. Here one set is there, but you are not finding any elements, therefore it's equal to empty set. You can use any one of the symbol. So A intersection empty set, you will get empty set only. Next, see, take U is equal to universal set is equal to 1 2 3 4 and 5, and set A is equal to take 2 and 4. Okay, now calculate U intersection A. U intersection A means writing common elements in U and A. Here 2 is there, here 2, 4 is there, here 2, here 4, only two common elements, that is 2 and 4. Okay, our observation is this is nothing but set A. So universal set intersection with the any its subset, then answer is subset only. Okay, then next see, take A is equal to set 1 2 3. Okay, find A intersection A. A intersection is nothing but set 1 2 3 intersect with the set 1 2 3. What's the common element? You will get 1 2 3 only. This is nothing but given set A. Okay, or in some cases they may give set A is equal to 1 2 3 and set B is equal to take ABC. Okay, question is find A intersection B. What's a common element? Here numbers there, here letters there. Is there any common elements? No, we can't find any common elements. So no elements. A intersection we say set with no elements, that is equal to empty set. Okay, by all these observations, our first note is A intersection A is equal to A. Second observation is A intersection empty set. We saw, right? A intersection empty set is equal to empty set. Third observation is universal set intersection with the given set A, then their intersection is equal to A itself. Okay, remember A intersection A is equal to A. A intersection empty set is equal to empty set. U intersection A universal set intersect with the given set A, then answer is equal to A itself. Next is difference between any two sets. Okay, let A and B are two sets. Okay, then A difference B. That means A minus B. A difference B is equal to set of all x such that x belongs to A and x not belongs to B. Okay, this is the meaning of A difference B. That means all the elements of A which are not in B. Okay, A minus B means you need to write all the elements of A but that element are not in B. Okay, in the example you can see set A is equal to 1, 2, 3, 4 and set B is equal to 4, 5, 6, 7. Okay, find A difference B. A difference B is equal to all the elements of A 1, 2, 3, 4 is there which are not in B. Okay, you're not bothering about set B. You need to talk about, we need to check A only. Write all the elements of A, but that elements are not belongs to B. So you can write 1 because 1 is not in B, 2 also not in B, 3 also not in B. But what about 4? One more element 4 in the set A, but that 4 also in B. So you need to write only 1, 2, 3. Clear? A difference B means elements of A which belongs to A only but not B. Okay, for example, see set A is equal to ABC and set B is equal to DEF. Okay, what is A difference B? A difference B is equal to elements of A which are not in B. Okay, what are the elements of A? A that is not in B. Then element B that also not in B. Then element C that also not in B. Therefore, it's equal to ABC only. Take the next example. A is equal to take 1, 2, 3, 4 and B is equal to 1, 3, 5, 7. Find B difference A. B difference A. What is B difference A? Elements of B which are not in A. 1 that is in A. Here you can see. Then 3. 3 also see. 3 also in A. Okay. 5 and 7 are not in A. So your answer is 5 comma 7. This is a value of B difference A. Okay. In the above example, what is B difference A? B difference A is equal to, see, elements of B which are not in A. Here only 4, right? 4 is in A. Write the remaining element, that is 5, 6, 7. Okay, what is B difference A in the second example? B difference A is equal to elements of B which are not in A. Okay, D is not in A, E is not in A, F also not in A. So B difference A is equal to D comma E comma F. Okay, now here find A difference B. A difference B is equal to elements of A which are not in B. 1 is in B, 2 is not in B. So 2 we can write 3 is in B and 4 is not in B. So 2 comma 4. Okay, this is the value of A minus B and B minus A. And take A is equal to 1, 2, 3, 4 and B is equal to 1, 2, 3, 4, 5, 6, 7. Okay, in this case, what is A difference B? A difference B, elements of A which are not in B. 1 is in B, 2 is in B, 3 is in B, 4 also in B. That means no elements, right? So it's equal to empty set. Okay, in this case, we will get empty set. But calculate B minus A. B minus A, it's equal to elements of B which are not in A. What are the elements of B? 1, 2, 3, 4. This much elements 1, 2, 3, 4 are in set A. Write the remaining elements, that is 5, 6, 7. Okay, this much possibilities are there. So it's a value of B minus A. Remember, difference of two sets A minus B means you need to write elements of B. You need to write elements of A which are not in B. If question is B minus A, write elements of B which are not in A. Next, symmetric difference of two sets. Okay, let A and B are two sets. Then symmetric difference so A and B is denoted by, okay, A, this triangle B. Okay, this represents a symmetric difference and is defined as, okay, A symmetric difference B is equal to A minus B union B minus A. A minus B union B minus A, that gives symmetric difference of A and B. Okay, for example, see, A is equal to 1, 2, 3, 4, 5 and B is equal to 4, 5, 6, 7. Okay, in the next case, calculate A minus B. A minus B means elements of A which are not in B. 1, 2, 3, right? 1, 2, 3. Okay, 4 and 5 are in B. Then what is B minus A? B minus A is equal to elements of B which are not in A. 4 is there, 5 also in A. So remaining element is equal to 6 and 7. Now write A symmetric difference B is equal to A minus B, that is 1, 2, 3 union B minus A equal to 6, 7. What you will get? A symmetric difference B is equal to 1, 2, 3, 6, 7. That means the symmetric difference, you need to remove the intersection elements of two sets and combine. Take this one more example. Set A is equal to 2, 4, 6, 8, 9, 10 and set B is equal to 1, 3, 5, 7, 9, 11. Okay. Now calculate A minus B first. A minus B is equal to elements of A which are not in B. What are the elements of A which are not in B? 2, 4, 6, 8, 10. Because see 9 that is in B, right? So you need to write the remaining elements. Then B minus A. B minus A is equal to elements of B which are not in A. 1, 3, 5, 7, 9. See 9 is in A. Then 11. Okay. Question is A symmetric difference B. A symmetric difference B is equal to, you need to take A minus B union B minus A, right? A minus B is 2, 4, 6, 8, 10 union B minus A is 1, 3, 5, 7, 11. Okay, combine this one, what you will get? It's equal to 2, 4, 6, 8, 10. Then 1, 3, 5, 7, 11. Okay, this is the possibility for symmetric difference. Remember, symmetric difference is nothing but A minus B union B minus A. Next is complement of a sector. Let A be any set and U be the universal set. Okay, you are taking one subset of the universal set, then complement of set A denoted by A dash. Okay, complement is denoted by A dash, is given by A dash is equal to set of all x such that x belongs to U and x not belongs to A. Okay, set of all x such that all the elements belongs to u and that element are not belongs to a. Or you can write, see, it's a definition of a dash is equal to u minus a, right? What is a minus b? X belongs to a and x not belongs to b. Then what is x belongs to u and x not belongs to a? That is u minus a, right? This is the formula. Okay. A complement is equal to u minus a. That means you need to write all the elements of u and that elements are not in a. From the universal set, you need to remove set a, that gives a complement. Clear? For example, see, universal set u is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a universal set in the given context. And take set A is equal to 2, 4, 6, 8, 10. Okay. Now see, what is A dash? A dash is equal to U minus A. It's equal to elements of U which are not in A. 1 is not in A, but 2 is there. 3 is not in A, but 4 is there in A. Okay, 5, then 7, then 9. Okay, this is A complement value. Clear? And take U is equal to A, B, C, D, E, F, and take set A is equal to AB, set B is equal to AC, and take set C is equal to EF. Okay, first find A dash, A complement. A complement equal to U minus A. What is U minus A? It's equal to A and B are in A, right? Write the remaining elements, that is C, D, E and F. What is B dash? B dash is equal to U minus B. Elements of U that are not in B. A is in B, but B is not there. B, but C also in C also in B, right? So write the remaining elements, that is D, E, F. Clear? B dash is nothing but U minus B, elements of U which are not in B. Then calculate C dash. C dash is equal to elements of U which are not in C. Okay, that is A, B, C, D. Okay, because see here E and F also belongs to C, right? So you need to write only elements of U which are not in set C. So it's equal to A, B, C, D. This is how to write the complement of the given set. Okay. Now some formulas related to complement. First one, A intersection A complement. A intersection A complement equal to empty set. Okay, remember the formulas. A intersection A dash equal to empty set. And second one is A union A complement. A union A complement. Its value is equal to universal set. Okay, A and not A. If you combine both the elements, you will get universal set. You can check that in the previous examples. Okay, and third note is A complement whole complement. It's a very important rule. A complement whole complement, its value is equal to A itself. Okay, then fourth one is, okay, universal set complement. Universal set complement means it's equal to empty set. Okay, why? Because U dash is equal to what you will get? U minus U only, right? U minus U, it's equal to not 0. It's a set, right? U minus U is equal to empty set. Then fifth one is empty set complement. Empty set complement is equal to universal set. Why? Empty set complement is equal to universal set minus empty set. What you will get? It's equal to universal set only, right? So these are very important formulas. First one is A intersection A dash is equal to empty set. A union A dash is equal to universal set. Third one, A complement whole complement equal to A. Fourth one, universal set complement. That means everything complement is nothing then empty set complement, nothing complement is equal to universal set. Okay, these are very important. U dash is equal to empty set dash is equal to U. Okay.